Hi, I'm Dave Rapson. I'm a professor of economics at the University of California at Davis and a policy advisor and senior research economist at the Federal Reserve Bank of Dallas. Thank you to the organizers for inviting me to give this address, which I'm honored to do. Today, I'm going to be talking about what the energy crisis tells us about the prospects for electrification, which is one of the central pillars of climate policy. And much of my thinking on this topic has really been enhanced by collaborations and conversations with Eric Muliger, Jim Bushnell, and Fiona Burlig, who are three of my main co-authors on a lot of this work. The views that I'm expressing today are my views alone and not the views of the Federal Reserve. So the backdrop for this talk is that climate change is accelerating, and I think probably most of the listeners of this talk already know this. It wasn't hard to find some examples of this. The headline I'm showing here shows that there were thousands of deaths recently in Spain and Portugal as a result of heat waves and wildfires. In the developing world, we're already seeing migration patterns changing as a result of heat waves and elevated sea levels, which are encroaching on coastal areas. And we expect that these effects are going to continue as the climate continues to warm and as we continue to pump carbon dioxide into the atmosphere. I wanted to show this particular chart, which is, I need to acknowledge my friend at Acorn Macro Consulting for making this, because it has a lot of content in it. First, it shows that in Europe and the United States, emissions have been declining for some time, which is really remarkable. We're decoupling economic growth from carbon emissions. At the same time, global emissions are increasing. And you can see that China is the major contributor. And I want to highlight the inflection point on this graph because I think there's a lot of information in terms of framing the context for this talk. So when China joined the WTO, all of a sudden you see the steepness of their emissions really increases. And the reason for this is, well, they're entering into a phase of remarkable economic growth, which helped to pull hundreds of millions of people out of extreme poverty, which is really an incredible accomplishment. And part of the activity that they were experiencing was an outsourcing from the wealthy countries in the world of their manufacturing capabilities. So instead of having relatively high polluting manufacturing in the United States and Europe, we instead would pay China to make those same goods and then send them back to us. And so this really emphasizes the global nature of the climate change problem, as well as the importance of taking a global perspective when considering the solutions to this problem. Carbon is a global pollutant, so it doesn't really matter whether it's emitted in the United States or in Europe or in China or even in the future, in the near future. All of these emissions are going to contribute to global warming. The second aspect of the backdrop is that we find ourselves in a global energy crisis. And this has been in the works for some time. It certainly was accelerated by the Russian invasion of Ukraine, but even the long-term input to the energy crisis is a reduction in investment in fossil fuel exploration and development because we're concerned about the climate. So this actually makes sense that that there has been an adjustment in our investment patterns. But nonetheless, this has led to tighter supply. And the executive director of the IEA says the world has never witnessed such a major energy crisis in terms of its depth and its complexity. And that certainly rings true. So on the one hand, we've got European gas prices that are going through the roof because Russia is curbing the flow of natural gas through the Nord Stream pipeline. This is something that's already happening. It's something that we envision happening potentially through the winter and even into mid-2023. And as a result of this, we can see that electricity prices a year from now are predicted to be 10 times as high as they were for the decade preceding the pandemic. That is a dramatic shock to an economy to make one of the most important energy inputs so expensive. And of course, this has knock-on effects. When natural gas gets more expensive, they're going to look for alternatives. And what is an alternative that's recently been phased out? It's coal. And so you can see that coal prices in Europe and Asia are rising as a result of the scarcity in natural gas markets. Of course, this is not what you would want as somebody who is concerned about reducing carbon emissions. Nonetheless, it's a rational economic response to the scarcity that we're seeing and the needs, the centrality of energy in the economy. One of the things that we learn from this is that economic concerns trump climate concerns. This might not be the way we feel in our hearts, but this is something that is exhibited over and over again. I want to highlight that as energy prices have increased in the EU and the US and well, really worldwide, most countries have taken steps to reduce energy prices, which of course is, it's good for economic growth and for people's pocketbooks. But if the energy is linked to greenhouse gas emissions, reducing the price isn't what you want to do. You want to do the opposite. And so in the EU, most countries have reduced their energy taxes. This has happened in the UK, Germany, France, Spain, Italy, and other countries. In many US states, there have been gasoline tax holidays. And why have governments been making these decisions? Well, it's because the populations of the planet has basically given a very clear message that, hey, we care more about our day-to-day well-being than we do about things that might happen in the future or definitely will happen in the future, but it's in the future and it's not right now. So we saw this in France as part of the Yellow Vest protests in 2018 when diesel prices were increasing. We saw it in Sri Lanka very recently when there was a series of economic calamities that led to the overthrow of the government. And the message is loud and clear. Politicians need to attend to the day-to-day needs of their constituents. Now, you might say this, well, that's not the way it should be. And perhaps that's right. But I think interpreting this as populism gone awry would not be the most productive way to frame it. And the reason is because there actually is tremendous value in transportation and energy services. And, we can see that by just thinking about the blue collar worker who's commuting from the exurbs into the center of the city to work and support the economy. That uses energy. We can think about it in terms of the electronics that we ship from Asia to the US. That takes a lot of energy. And the abundance and selection of goods that we enjoy in our economy really are a result of integrating economies worldwide, which takes a lot of energy and produces carbon emissions. And the value of trade is enormous there. And in a really wonderful paper, Joe Shapiro, an economist at Berkeley, estimates that the value of international trade exceeds the climate damages by about 161 to 1. So really the benefits are enormous relative to the climate costs as much as we care about the climate costs. One of the things that we want to guard against is throwing out the benefits as we try to solve the problem of carbon emissions abatement. What does this imply for climate policy? Well, first, that energy security and reliability have to be top priority. But second, costs really matter, and so do the incentives that are set by the policies that we implement. And that's important because just the sheer magnitude of the task at hand. And finally, solutions have to work not just for the OECD, but for developing economies as well. So today I'm going to examine a central pillar of climate policy, which is electrification. What is the electrification vision? Well, the first step of it is to take a very fossil heavy electricity grid and turn it into a renewable grid. So we want there to be lots of wind, lots of solar, lots of batteries, so that it's very clean to charge to meet our energy needs from this now clean grid. And once we do that, we'll be able to shift away from gasoline and diesel cars and instead power our transportation needs by electricity. This is the vision. And it's an enticing vision because we're already making great steps towards achieving it. Now, one of the challenges is that the majority of electricity worldwide is actually produced by fossil fuel generating sources now. So 60% of the world's electricity, mostly coal, is powering electricity. So this is a first order concern. One might think that we would want to do the first step in electrification, this decarbonizing the grid, before we move too rapidly on the second of electrifying transportation. We're seeing really encouraging signs for grid decarbonization, and I just want to show a couple bits of evidence of that. So here we're looking at the Energy Information Administration's plot of annual electricity power sector generation by source. So you can see here that coal has dropped by roughly 50%. It's gone up a little bit in the pandemic, and as I mentioned earlier, it's meeting some energy needs worldwide. But really, we're starting to really see dramatic declines over the long term in coal on the grid. And that's largely because of increases in natural gas. So these are quite substitutable for the reason that natural gas and coal are both dispatchable. You can turn them on and off, and you can turn them up and down. And the other component of the electricity mix increase is wind and solar, which of course is part of that zero carbon electrification vision. Those are less substitutable for coal and natural gas unless we have batteries. And fortunately, batteries have been coming down in cost as well. These allow us to store electricity when it's abundant, in surplus perhaps, being generated by wind and solar, and then use it later when the wind isn't blowing or the sun isn't shining. The costs of batteries have fallen by roughly 90% over the last decade. So that's really an incredibly encouraging accomplishment. And hopefully that's going to continue. But right now, the US is at 21% renewable electricity. And it's worth asking, is 100% renewables a realistic target? In order to make that happen, we need to think about not just having a small amount of intermittent renewables on the grid. These are wind and solar that aren't producing all the time, but we have to plan for periods of time when perhaps for days or even a couple of weeks, there might be cloud cover, there might be no wind. And in those cases, there's going to be a requirement for a substantial amount of battery storage. This is going to help to integrate renewables in the short run, so when the short-term fluctuations in supply, but also in the long run when there are prolonged reductions in renewable supply. In order for this to happen, we really need grid-scale economical storage. And right now, we're not quite there. So that's a question. Are we going to have sufficient innovations in battery technology to get to 100%? And what does it look like going from 20% to 30% to 50% versus 50% to 75% to 100% on the grid? It's quite possible that the costs associated with ramping up to 80, 90, 100% are a lot higher than we would hope them to be. There's a question as well about the supply of rare earth metals, which are essential inputs to the manufacture of batteries. As we dramatically expand the demand for batteries in the world, these rare earth metals are going to become, well, rare. And we're going to have to figure out ways to get them to market at higher volumes than ever before. This is a genuine constraint. There are questions about the role that EVs will play in storage. Will they provide vehicle-to-grid services? Of course, if you're using an EV as a battery, you can't use it as well for transportation. It's kind of one or the other, but they may be helpful. Can we build enough transmission lines in order to integrate the new supply of renewables into the grid? Of course, retail electricity tariff reform would be very beneficial, allowing the price to reflect scarcity in the market through real-time pricing. Of course, nuclear, there may be a role for this as well. And all of these questions are going to be important for how quickly, how cheaply, or even whether we end up at 100% zero carbon electricity. So I want to switch gears now, no pun intended, over to electric vehicles. And I want to start with a success story. So in Norway, in March of 2022, 92% of their cars were plug-in and hybrid electric vehicles. So this is a really remarkable achievement, and one that many advocates and environmentalists would like to replicate in other areas of the world. How did they do it? Well, they didn't do it the way that we're trying here in the US with massive subsidies. They didn't have subsidies, even though they had plenty of soft incentives for EV drivers. Instead, they imposed a high tax on gasoline and diesel cars, and they exempted EVs from that tax. This is an important distinction, because if what we really want to do is reduce the use of gasoline, it helps to make it more expensive, or make the durable goods that consume it more expensive. So I really like this distinction. It's one that I think policymakers worldwide should learn from. Of course, there's one feature of the Norwegian setting that's very appealing, which is they get 98% of their electricity from hydro mostly. And so we're getting a lot of emissions abatement from switching VMT from gasoline and diesel to electricity in Norway. I already showed you the electricity generation mix worldwide. This would not be quite as good a situation in most of the rest of the world. EVs are on the rise in the US. As we can see, over the last 7 years, they've gone from just over a 0.5% market share to a 3.5% share in 2021. So, should this be viewed as a sign of success? And I just want to emphasize that it really depends. This in and of itself is not a marker of us solving the problem. The problem is we would like to reduce carbon emissions. That means displacing gasoline VMT, and simply adding more electric vehicles does not necessarily do that. So with that in mind, I want to turn to a little bit of research that I've been doing with several co-authors. And one of the main objectives of our research, or one of the central questions, is how much are EVs being driven, and how much electricity do they use? So we've partnered with electric utility companies. We've got DMV data that we can match to household level meter data, and we can see when an electric vehicle arrives at a household and what that does to electricity demand. And that's what I'm plotting here. So on average in California, when an EV arrives at a household, that increases kilowatt hours per hour consumed at that household by about 0.12. And we can take that estimate of home electricity use for EVs, that home charging, we can adjust for away from home charging, for which we have a pretty good estimate, we think, on aggregate, although there are some, certainly we'd like to have even better data. But we can adjust for away from home charging. We can adjust then for the fuel economy or fuel efficiency of the vehicle to estimate how much these cars are being driven. And what we're finding is that our best guess is that these cars are being driven substantially less than gasoline cars. We find that EVMT in our sample is roughly about 6,700 miles a year. Say, gasoline cars are driven roughly 10,000. That's a 1/3 decline, or one third gap that needs to be explained. And again, what we care about in as far as carbon emissions go is how much are we displacing VMT and gasoline cars. Well, if EVs aren't being driven as much as gasoline cars, maybe they're not completely substituting gasoline VMT. So that leads to several potential explanations, which I would maybe call research hypotheses. We would like to test which of these explanations make sense. So is it just because of battery range, which is rapidly increasing, or battery size and EV range, which newer cars can be driven a lot farther, and people care about this? Is it just that early adopters are different than drivers in the future who are going to drive more? Is it that people who buy EVs are adding them to a household portfolio that already has a few cars in it, and they're just kind of maybe dabbling? They're saying, okay, I want to have a clean EV, but I'm not going to get rid of my gasoline car yet because maybe certain trips are amenable to gasoline, the gasoline technology, the long range trips, for example. Could it be because electricity prices in California are very high? So each of these hypotheses would, if there's evidence for it, it would lead to different implications for the transportation electrification vision. And we're trying to answer these in some ongoing work. And one of the only result really that I want to show from our upcoming work is this plot of EV range in terms of miles that you can drive on a full battery against our estimate of how much these cars are charging at home. And if battery range is the only factor that's relevant here, then we would see just a simple upward sloping line. That's not really what we see. What we see here is for basically every car except Teslas, these two dark dots up here on the right, those are Teslas. They're being charged and driven a lot. In fact, we think that they're being driven basically about the same as gasoline cars. But all of the other EVs, the plug-in hybrids, as well as the low-range battery electrics, appear to be at least charged at home substantially less than Teslas. So it doesn't look like battery range answers the entire question. So we're also digging into the portfolio questions. Are EVs actually substituting for gasoline cars in the portfolio? We're going to have some work coming out on that soon. I want to shift gears finally to the developing world and whether electrification is a suitable or viable option for them. Most people on Earth don't have reliable electricity. We're very fortunate in the OECD, the wealthy countries, to have very reliable electric grids. That is not the norm. Nonetheless, as people in the developing world get richer, which they are, which is a great success of the modern global economy, they're going to be demanding more energy services. And there's a real question about how those services are going to be met, with what technologies. And you can think about there being two choices for transportation. There can be, are we going to buy oil and refined products and fuel our transportation from gasoline and diesel? Or are we going to build an electric grid and charge our electric vehicles on that grid? And those are going to be probably very different options with different time profiles of investments and different overall costs. And so there's a question, will these countries be willing to pay more for clean electricity than for other energy options? It's almost certain that the electric option is going to be more expensive, particularly if the rest of the rich world successfully gets off oil, which would, cause the price of oil on global markets to decline quite a bit relative to today. Right. So what will happen if the price, if the oil price, if OECD countries successfully electrify transportation? I think, considering these second order knock-on effects is really important. It's not just about what we see, it's about what we can't see and what's going to happen in equilibrium as we play this all out. Okay, so in summary, I would say that electrification is not a silver bullet. So recall that from our current events, energy security and reliability are paramount, and it just so happens that liquid fuels, fossil fuels, are pretty reliable and pretty secure relative to electricity at the moment. Cost matters, and again, this is a shifting landscape, and certainly, there is a case for EVs being economical today in some places, but in many places they remain more expensive even in the face of battery cost declines, and that's frankly why we see so much government subsidy and stimulus for the EV industries, because they're still more expensive. And solutions must work in developing economies, not just in the OECD. These are real challenges for electrification. Summary point two, we're still in the very earliest stages of electrification, and there are so many questions that remain unanswered. This is a boon to researchers because we have probably many lifetimes of questions to answer that are important. But from a policy perspective, I think it points to the need for humility as we consider the path forward. Are we going to take all our chips and shove them in the middle for electrification, despite the fact that we still don't know answers to many of these important questions? Or are we going to, take an approach that allows many other technology pathways to be nourished as well, leaving our options open? Of course, it's imperative to take a long run view. And here I just want to highlight that we are emphasizing as a global climate community achieving temperature gains that remain below 1.5 degrees. But this is not exactly like what happens if we don't meet that. Well, probably the marginal benefit of emissions abatement, if we've hit 1.7 degrees or 2 degrees, the marginal benefit of abatement is going to be even higher than. We want to really continue to ratchet down emissions almost no matter what temperature we find ourselves at. There's going to be big gains to emissions abatement. So taking this kind of threshold view, I'm not sure that it really frames the circumstances in the most helpful way. So my recommendation based on all of this is that, if we're facing risks, we should buy insurance. And what does that mean in this circumstance? Well, we want to pursue policies that are going to spur innovation along multiple potential abatement pathways. We don't want to just focus on batteries and electrification, even though those are very promising, and of course, we need to invest in those. But I think we really need to also invest in carbon removal, small scale nuclear, hydrogen. There are probably many other projects that you, the listener, is thinking of right now that's not on my list. And what that really speaks to is the importance of implementing technology neutral policies. Making it more expensive to pollute is going to create headroom for innovation on any alternative technology. That's exactly what we want. Things like a carbon tax, a cap and trade, they're going to set the right incentives to, or at least go in the right direction. They might not be the only things we need to do, but they're at least going to create headroom for innovation in all sorts of important dimensions. So technology neutrality, in my view, epitomizes the extent of humility that really is appropriate based on what we know and don't know and the magnitude of the task in front of us. So thank you for listening. I appreciate that you made it this far. If you have comments, please email me. My email address is dsrapson@ucdavis.edu. I'm trying to be a little bit more active on Twitter. If you want to follow me on Twitter, you can find me at Rapson Energy. Thank you.